Alright, these are 8-5 notes part 2. To continue on here with problem number 8. So our goal once again is to determine if line AB or line segment AB is a tangent to the circle. So is that orange line tangent to the circle? Is it just touching? So in order for it to be tangent, the requirements are it needs to be a right angle with the radius, aka it needs to be 90 degrees, and it can only be touching at one point. Well, we can see it's only touching at one point. And now we just got to determine all the side lengths. So we know the orange side length is 4, the radius is 1, and this little piece from here to B is also 4. So one thing you also have to point out and see that the radius, if the radius over here is 1, that means this radius is also 1. So this full hypotenuse length is 5. So we got a total of 1, 4, 5. So we do 1 squared plus 4 squared. Does that equal 5 squared? Well, 1 squared you know is 1, 4 squared is 16, and 5 squared is 25. 1 plus 16 is 17. 17 does not equal 25. Since it does not equal, it's not tangent, meaning that this is not a right angle. Let's do another one. Number 9. So our goal is to determine if this red line AB is tangent to the black circle. Red line is 16 in length, the radius is 12. Once again, they didn't label the radius over here, so we have to label it ourselves. So that's 12. 8 plus 12 is 20. So the hypotenuse length is 20 in this case. Now to determine if it's tangent or not, we do 12 squared plus 16 squared. So 12 squared plus 16 squared equals 20 squared. We crunch that out. We use a calculator to always double check everything, but 12 squared is 144. 16 squared is 256. So 144 plus 256 equals 20 squared is 400. Now what does 144 plus 256? Does that equal 400? You bet. So 400 equals 400. Slide that back into the picture. And since 400 equals 400, that means it's tangent. Just the same number. Number 10, we want to determine is this green line AB tangent to circle, the black circle. Right angle there. 4.8 squared plus 6.4 squared. Does that equal 8.9 squared? Well, 4.8 squared is 23. 2304. .4 squared is 4096. And 8.9 squared is 7921. When we add 23.04 and 49.6, add those two together, we get 64, and 64 does not equal 79.21. So 64 does not equal 79.21. Since they don't equal each other, it's not tangent. Alright, so now we have to practice a couple of those. Here's another little concept here for us to know. If two different lines are tangent to the same circle and intersect outside the circle, then the two tangent lines are congruent from tangent point to the intersection point. So what do I mean by that? So I'm making a green dot where the circle meets the tangent line. Both there and here. So we have two blue tangent lines. These two tangent lines, they intersect at this intersection right here, that green point. The distance between this green point and this green point turns out to be equal to the distance between this green point and this green point. That's what this theorem is saying. So this distance here is congruent to that distance. Those two distances are equal to each other. Kind of makes like a little bit of a snow cone, a red snow cone. Alright, so let's apply that concept to a couple problems. So here's our problem. It says solve for x, assume that lines which appear to be tangent are tangent. So that means, since we have a tangent line here and a tangent line here, those are the intersections. They cross each other here. That means this line and this line, these two tangent lines, are equal to each other. So then we have 2x plus 13 is equal to 1x plus 13. We do our inverse operations. Subtract 1x from both sides. So we get 1x plus 13 equals 13. Subtract 13 from both sides. 1x equals 0. So x is equal to 0 on this one. Which makes sense when we put 0 back in. 2 times 0 is 0. 1 times 0 is 0. So 13 equals 13. Cool. Let's do another one. So we know that these two tangent lines are equal to each other. So we then know 2x plus 32 is equal to 1x plus 32. Let's put it over here. A little bit easier to see. So in this case, we subtract 32 from both sides. We subtract 1x from both sides, and once again we get a 0. 2 zeros in a row. What do you know? Alright. These two are equal to each other. Hopefully it doesn't come out to be 0. 1x plus 1 is equal to 2x minus 9. We do our inverse operations. We're going to get, add 9 to both sides, we get 10. And subtract 1x from both sides. You get 1x, so 1x equals 10, so it'll be 10. Would be our answer. So x equals 10. Alright, look at this one. These two tangent lines, they're equal to each other. So we got 42x is equal to negative 1 plus 43x. Subtract 43x from both sides. So you get negative 1x is equal to negative 1. Divide both sides by negative 1, we get x equals 1. So it's B. Alright, looking at this one, it's going to be the same process. These two tangent lines are equal to each other because they intersect both the circle and each other. So we got 3x minus 7 is equal to 1x plus 11. We do our inverse operations. We subtract 1x from both sides. And we add 7 to both sides. So we get 2x equals 18. Divide both sides by 2 and you get x equals 9. Here's another one you could practice with. Another one. Another one. Bring that up, make it prettier. There's another one. All these problems are the same. Same stuff. Now, this is when it gets a little bit more different. So you see all the directions. Find the perimeter of each polygon. So our goal is to find the perimeter of this polygon looking figure. Kind of looks like a square, but it's not. Assume that lines which appear to be tangent are tangent. So we have a whole bunch of tangent lines going on here. Now, by definition, which I just told you about, was tangent lines if they're crossing each other on the outside of the circle, like we have here with these two orange ones. That means if this guy's 11.3, this guy's 11.3. Now, what makes it a little bit trickier, we got to find this red guy. To do that, we got to go around the circle here. Because unfortunately, it's not double. And it's not half. We have to do a little addition postulate around the horn here. So if we know that this guy is 11.6, that means this guy is 11.6. So if we do 24.6 minus 11.6, so 24.6 minus 11.6, we're going to find out that this color, I'll do it in purple, right here in purple, is 13. And if that's 13, that means this purple guy is 13. Now, we have to take that 24.7 and subtract 13. So 24.7 minus 13, and we're going to get 11.7. So this red guy, from here to here, is 11.7. So that means this guy is 11.7. Next up, we're going to add our givens. We're going to add up the perimeter. So I'm going to start on the top. I'm going to do 11.3 plus 11.7, because that's my top of the perimeter, which gets us 23. Then our side of the perimeter, well, we already know 11.7 plus 13 is 24.7, so I'm going to do plus 24.7. Then I'm going to add the bottom left there, which is the whole thing is 24.6, so I'm going to add 24.6. And then the left-hand side is 11.6 and 11.3. So plus 11.6 plus 11.3, and I'm going to get 95.2. And that'll be my answer here, 95.2. Let's do another one like that. So it's the same directions. I'm going to keep this picture kind of on the bigger side so you can see the picture a little bit better. Alright, so you know that this one's 10.6. Because that's 10.6, we know that this is 10.6. So I'll slide that in there. Now, we got to figure out, I'll slide that over. I don't want to use blue. Let's use purple. we got to figure out this purple side. To do that, we have to know what this purple side is, because those are the same. And we're going to find that purple side by using a 20.6. So we got to work our way around the triangle here. We know that these top two pieces, we got 22.6 and a 10.6. So we have a big and a small. So big minus the small will get us this other small. We'll find this green guy. So 22.6 minus 10.6 gets us 12. So this purple guy is 12. So if that that green guy is 12, this green guy also has to be 12. 20.6 minus 12, we put that in the calculator, and we get 8.6. So this purple guy is going to be 8.6. That's how I get that 8.6 over there. Then we add up all the sides because that's what perimeter is all about. So I do 22.6 plus 20.6 plus 8.6 plus 10.6. That's going to get you 62.4, which is C in this case. Let's do another one. See if I can make it a little bit bigger. There we go. That should be a little bit prettier to see. So we got all these sides that we're going to have to work with here. Alright. So what would I do first in this one? Well, we know this purple side, this tangent here is 14. So that means this guy here is also 14. 23.1 minus 14 is 9.1. So this red side here is 9.1. That means this side here, this red side here is also 9.1. So we do 19.6 minus 9.1, which gets you 10.5. So if that side's 10.5, that means this side is 10.5 also. So we do 16 minus 10.5. Get you 5.5. So this pink guy, or beige, whatever, it's 5.5. That means this beige guy is also 5.5. Now that we have the perimeter, we can add up all the sides and we get our perimeter. So we do 19.6 plus 23.1 plus 14 plus 5.5 plus 16, which gets you 78.2. So that'd be our answer here, 78.2. Here's another one you could practice with. Another one, another one, another one. Make it a little bit bigger. Another one. Another one. And here's the last one you can practice with. Alright, classwork and homework. If you guys have any questions, please email me or come to Extra Help. I'll be happy to help you out. Alright, have a good night.